This is Pythagoras Consult. Like we promised that we are going to follow the scheme of work one after the other. I think this will be the second topic for SS2. We pray that God assists us. We are going to stick to our promise. So let's move. Mathematics. Mathematics SS2. Like I do advise that SS3 too can keep watching, but the class is mainly for SS2. We are going to rush up to make sure that we finish because it entails two topic or subtopics. So we want to look at approximation of decimal and significant figures. So approximation of decimal and significant figure. We are going to start. This topic of approximation started in primary four. Primary four, I think, first time. Or even second time. Then again, they are going to meet it in JSS2. JSS2, I think, first time. Then finally, they are going to do it in SS2. So if they have done it, it should just be like a sort of revision. So let's start with nearest is, nearest that. We said nearest, it could be nearest 10, nearest 100, nearest 1,000, and etc. But I'll give one or two example. I think they can follow the trend. So when we are given 2, 5, 6, and they said we should approximate to nearest 10. Okay, let's say I nearest 10, I nearest 100. So let's add the 2. Or let me put like 7 so that we can say nearest 1,000. And we still add more. You just follow the trend. Number 1, let's look at the solution. Number 1, nearest 10 of 2, 5, 6, 7. First, when you are approximation has this symbol. The symbol, not like equal to like this, but rather the one at the top will be squeezed and the one at down will say approximated equal to. So this is the symbol. Take note, the symbol we are going to be using, not equal to. So approximation is basically moving towards the nearest. The nearest. Once you are at the middle, you move towards the upper. So let's move. When they say nearest 10, tens entails two numbers. Definitely we are concerned with the last two numbers. The last number is 67. So it means I'm moving 10, 10. I want to go and locate 67. 57 falls between 60 and 70. This is where it falls. When the difference or the gap of 10, I'll move according to it. Now, half of 10 is 5. So half of it will be 65. 65. Yes, 65. I'll now compare what I am, the last two with the middle. The middle is 65. If this is up to the middle, 67 of course is up to 65. Then I move to the end, the other end. I mean the upper end. That's the maximum. I move to the maxi. If it's not up to, I move to the mini. Now let me go. The maxi now, I will use it to replace that 67. So 2, 5, 6, 7 is approximated equals to I want to replace this one with 70. So it will now be 25. I'll write the number before it, 70. So this is nearest 10. Then let me move to nearest 100. Nearest 100, I am now concerned with last three number, as 100 is three numbers. That's 567. And this lies between 500 and 600. Like I told you, since it's near is 100, the gap will be what? Between hundreds. So half of 100 is 50. So half of it will be 550. 550, as half of this is 5 to be 60, 5 will be the half. I'll compare the number, the last three number, where's the last three number? This 567, this 550. Once it's up to this, I move to the maxi. Now I use 600 to replace this number. Therefore, 2567 is approximated equals to 2600. Now let's move to the nearest thousand. Nearest thousand of 2567 towards to nearest thousand. Nearest thousand. So 1,000 is 4 digits. So I come to this, you can still have it at 4 digits. So 4 digits, the 4 digits is 2,560. So 2,000, I'll move in thousand. So it's going to be between 2,000 and 3,000. You move in thousand. So half of 1,000 is 500. So it will be, half of it will be 2,500. 2,500. Now I'll now check my number. Compare it with the middle. Is it up to, yes, 2,500 and something, 2,005. So I move to the maxi. So I replace this thing with 3,000. So 2,567 is approximated equals to what? 3,000. So you can go on and on, going to 10,000. You move in 10,000, then 1,000,000, and like that. So this is approximation. Now let's go to nearest whole number. Nearest whole number. Whole number is the number without what? Decimal. Whole number is a number without decimal fraction. So without decimal point or decimal fraction, is not a number of fraction. Likewise, it's not a number after fraction. Although you'll be given the number with decimal, you are now asked to turn to number without decimal. So let's see example. For instance, you are given 29.5. Let's say 6. You now say you should change to what? Nearest whole. That is, make this number whole. Whole number is the number before decimal. So this number now, 29.56, will be approximated equal to, this is what I need, the one before decimal, fine. But I must still consider the neighbor, the one first number after decimal. I'll consider it. Look at it. Is it up to 5? If it is up to 5, then I will change it to 1 and add it to my old number. So it will be approximately equal to 30. You can see that 30 without decimal. Are you getting it? So let me give one more example. Let's say I'm given 159 points, let's say 76. So nearest whole number, like this is the number that I'm concerned with, but I'll consider the first number after decimal. Is it up to 5? Yes. I will now change it to 1. Then I add it to this, so it will be 160. And likewise, if I am given this type, 39.45 is approximated equals to, I'm concerned with this 39. Of course, I'll look at the first number. Is it up to 5? No, it's not up to 5. So my old number will remain 39. So let's go to near decimal place. Decimal place. Decimal place. Decimal place is denoted with DP. DP. What does it mean? Decimal place. Now, decimal place is opposite of whole number. This is number after the decimal point. So, decimal place are the digits after the decimal point or decimal fraction. So we mean the number after the decimal now. So this one now has series of types. It has one decimal place. It's called 1 dp. It has on and on like that. Two decimal place is called 2 dp. And like 3 decimal place, that one 2, 3 dp, 4 dp, and like that and like that. So let me give example. If they actually said, write 345.66 in 1 dp, that is 1 decimal place, I am actually concerned with all the number from beginning to the first number. Since they just say 1 dp is just one number after decimal, but I'll consider the one after it. If it's up to 5, I change it to 1, add it to the previous one. So 345.66 is approximated equals to 345.7. So this one will change to 1 and add to this. So let me give another example. 1.598. Okay, let me say 99. They said to 2 dp. Now converting this one to 2 dp is normally pose some difficulties to students. So 2 dp now from beginning to 2 number after decimal. Now I'll now look at the next one. Is this one up to what? 5. I'll now change it and add it to this. Now if I add 1 to this one, it will become 10 again. It will become 10. And 10, I cannot write 1 0. So therefore, 1 will still come to this, and here will go the 0. So this one will now be approximated equals to 1 point. Look at it very well. This one, I am concerned with 2 number after decimal, but this number, I will consider it. If I'm considering this one is up to 5, I add it to this. If I add 1 to this 9, it will be 10. So when it is 10, it will still come to this side. So it will now be 1 0. Approximated, because this one will turn to 10 and it will come near. Sorry, I said 1 0. It will turn to 6 0, because this one, the one will come to this 5, turn to 6, whereas this one will hold 0, 6 0. So let's take note of search. So let's go to significant figure. Significant figure. All this one, I do teach them in basic 4. I'll finish it when you get to GS2. We'll just make a kind of revision on them, and then it goes. Now, significant figures, they are number other than zeros, but it could be significant I said they are number other than zeros. That is at the beginning. Zeros could be significant when it's at the middle. Eh? We said they are numbers other than zero. So the condition there, zero could be significant when it's at the middle because it holds value at that side. The one at the beginning actually holds value, but it's not like the one at the. So here too, we have one significant figure. That one we call it 1SF. So and we have 2SF, significant figure 3SF, and like that and like that. And just like that of decimal place. So let's now give example. You might be given 6, 7, 8, 9. So they just say to 2SF. So you see that this one there's no point. So it doesn't mean two significant figure, and I say other than a zero. So starting from 1. So we are concerned with the first two. First two. But you are going to consider the next one. If it's up to 5, we'll make it 1 and add it to the one before it. So 6, 7, 8, 9 is approximately equal to, this one now becomes 68. Then the remaining number will now change to zeros. This one, 8 represents 0, 9 represents 0. So 2, you could be given very long number, 6, 8, 9, 4, 5. So when someone say 3SF, 3SF, you are concerned with just 3 number here. You check the next one, is it up to 5? Yes, you add it to this. So it will be approximated equals to 6, 8, 8. Then all this number will turn to zeros. So that is it. But it has the negative part, the decimal of a negative part. So when you have a 0.00246, and it said 2 significant figure. So now all these zeros are irrelevant, like I said. So starting from 1 or 2, so this is the first significant figure. Add it there plus this one, making 2, as in not plus, add to including this. So making 2, this and this from beginning you write up to this place. Now you consider the next one, is it up to 5? Add it to the one. So it's approximately equal to 0.0025. You can see 2 significant figure, 2 significant, and the likes. Now we are going to move to, we said we are moving to percentage error. I think they are both in one week. Percentage error, it is the difference in measurements or change in measurement as a result of error. So we say first say what is error? Error is the difference between the actual and the error committed. The actual. So error is the difference between the actual and the, let's say, mistake made. So when you make mistake in measurement, obviously made in, let's say, measure. So when you made mistake in measurement, in accounting or mathematics term, we say you committed what? Error. So there is going to be two things. You're supposed to make one. This is the real and the one that you make. So there is error. So if we subtract it, we get the error. But when we now say percentage error is the, we call it let me use degree. I call it the degree of change in, is either exact or actual. Call it any of the two. And error mode. So looking at this, we will call it, okay, you can say the degree of the change in them. So we are going to look at it. It's very simple. When you hear percentage, that tells you that they are comparing the difference in them in division of hundreds, and see how the percentage is big, or magnitude, or the size of the percentage. Now let's go to example. Let's go to this example. I have chosen this example because of its relationship with our previous subtopic. A man estimated his transport fare for a journey as 210 instead of 220. Find the percentage error in his estimates correct to three significant figures. And that's where they use those approximation. Now let's move solution. Our solution, they said we should first know that our percentage error, the formula is just like very simple, very simple. We have difference that is difference in measurement divided by actual, multiplied by 100/1. Why am I using difference? So some will say old minus new divided by actual, and so some will say they have a lot of formula, but why do I use this difference? In economics, we make use of what? Change. That's what we use. Change over actual times 100/1. Why do we use change? Why do we use this change? It has relationship with differentiation, but then that is the economist. So difference, percentage error could be increase in percentage, or it could be decrease in percentage. So if it is increase, it means the error made will be bigger. So there could be increase in percentage, there could be decrease in percentage. So just use this one, difference in them. Now let's look at it now. If you look at this one, there is the error is increase. So this one you now say new minus old. The decrease now it will be old minus new. Anyway, just difference. So let's go. What will be the difference here? 220. So make error of 210 all over. This is the actual Actual is what that thing's supposed to be. So the fee is supposed to be 200 and what? 20 multiplied by 100. That's why we call it percentage. So this thing now we are rating it. What is that your error out of 100? So let's still move. If we subtract this one will give me 0, this to this 1, and of course this one 0, all over. And the next, we can now continue to do our cutting. The 0 cancel 0. I think 2 here is 11. Of course, 2 here is 5. I've used the 2 to divide this. Now, let me now move on. What will I have? I'll be having 10 times 5, that's 50 all over 11. 50 all over 11. Since they said I should leave in 3 significant figures, it means I must put my answer in decimal. How many 11 can I get in 50? I think I can get 4, which is 44. 44 here, I'll be left with 6. So I put 11 cannot actually go in 6. I put my point, add a 0 to this. In 60, I think it's going to give me 5, which is 55. The remaining 5. In 50, I'll add a 0 again. In 54, remainder 6. 5, remainder 5. 5, yes, remainder 5. 4. Now, don't forget the answers to put it in 3 significant figures. Just 3 significant figures. First 3 number 1, 2, 3. We are concerned with this. But 3SF now will now be equal to approximated equal to. I'll consider the next number. Is it up to? Then I add it to this. So it will be 4.55. Percent, you must put this percent to tell you that, oh, the error he has committed is not much, it's just 4.55%. Mind you, this is not 4.55%. This is not a real number, it's not whole number. Don't call it 4.55. It's 4. Call them in digits after decimal. I think perhaps let me do one more. Now this is the second question. Let's see solution. It said a boy, when rounding up a number, wrote 98 instead of 980 to 2 significant figures. What is the percentage error? So we say our percentage error, you can say is error, let's say the error over actual, or is that, sometimes they say is that. It's still the same thing. I'm using different types so that the textbook doesn't matter. It does what you know. So the error will now be 980, which of course is the bigger one, minus 98 divided by that 980, because that is the actual times 100, is that. So let's subtract. So this one will give me 2, and this one is 7. 17 minus 9. 17, remove 9. I think that's 8. So this one will now remain 8. So we have 8, 8 all over 980. So multiply by 100 over 1. So let's move. We still have 882 all over multiply by 100. Now we can now cut. I don't encourage you cutting at this thing or dividing at that thing. This divide by this. So 2 can do something here. So 2 in 98, I think 2 here is 4, remainder 1. Here will now be 9. The 2 that we use for this, we use for this. 4, 4, 1. I think 7 can do something here. 7. 7 here. 7. Let's see if 7 doing something. 7 in 44, I think that's 6, which is 42. So remainder 2, this one will be 21. 7 in 21, that is 3. 7 can still do something interesting. 7 here 1, 7 here 18, that's 9. So we only have 9 times 10, which is what? My answer is equals to 90%. So the percentage error is 90. You see, the person will now know. So I made this big error, 90%. 90%. So I will encourage SS2 to do this assignment. In this class, this is the assignment. A sales boy gave a change. Call it change. change. Change in what it should be a balance. A balance of 68 naira instead of 72. Calculate its percentage what? Error. Now, this video is meant for SS2 and SS1, a very inquisitive SS1. But if you show your child that, oh, look at it, say this is simple now, ask him to sit down and solve it. If you solve it, if you are not sure, send it to me. Or you send it to this WhatsApp number, and I'll be able to reply you. I think 08099540493. So this is the WhatsApp number. I don't know how you people spell your WhatsApp or so anyhow. WhatsApp. So this is the WhatsApp number. Let's send it to this WhatsApp number. I'll be able to confirm, because some of you now comment and subscribe. Some will find it, I don't know. Some will find it difficult. If it is those comedians, you say, I beg you, comment. And some of you will comment, I beg you, subscribe. You will subscribe. If you can subscribe to common comedian and you are making them rich, they have big houses, they have big cars, and they are still telling you, please subscribe, and your kids can watch them. I don't want to mention names, you know them. So subscribe to this one, that will be forever. It will develop their calculating skill. And it's there forever for them. Once they know this thing, nobody can take it from them. Even though their enemy that didn't want them to know it can take it from them. So it's just simple. If you subscribe there, it keeps you encouraging us. It keeps you encouraging us to do more and more. Like I said, it's actually not the barrier, but then this to give back. But then there's no problem with any of the assignment given. If you can't send it on the YouTube, then come and send it here to this WhatsApp number. By the special grace of God, I will answer you. So I remain Pelumi. Have a nice time.